Hi, I'm Isaac, and I'd like to do a tutorial that covers not only 3D CAD, but also the product life cycle process, which means create an idea and then how to bring it to life, and not only to manufacture, but how to communicate to vendors, how to keep track of iterations, and to show that the process with today's technology is relatively straightforward, that pretty much anybody should be able to do. And as an introduction, I came up with some questions that people might be thinking. How could I bring a product into existence? Where do I start? Hasn't everything already been invented? All these large companies out there, can't they create the solution for product ideas? What hope is there for a small person or small business or an individual to, like myself, or to have a chance to do this kind of thing? Is it too expensive? Do you need investors? What resources are available to bring products to life? Is there anyone out there that can help me? So what I like to do is answer these questions, and they can first start off with just picking an idea that may be a very big idea, maybe insurmountable, but you know, that's how the product life cycle starts. And you'll find other tutorials out there for 3D CAD tutorials and how to click the right buttons to generate the right 3D object. But life is not like that. Life is basically, I'm not sure what I want, but I want to try a few things here and there and see if I get to some idea if it's going to work or not. And I don't even know how to fit part A to part B, because there is no part B for part A to fit to. So there's literally nothing to start from. And what I'd like to do is just dive into it and then just assign ourselves a project. And so my idea, before we start getting into the tutorial, is, well, laptops these days seem to be lacking features like basic headphone jacks or SD card slots, or even the size that I particularly like. And this is actually a 2011 MacBook Pro that I'm still using till this day for all my design that I do. And I'm let's, for example, don't like what's out there. So what if I actually took upon myself to actually design a new laptop from scratch? Okay, where do I start? Where do I, all these questions come up. So let's just start from what I like and what I want. I like the big screen because I don't like plugging into a monitor, and then I like the size and weight. The power supply is not this giant brick. The battery life isn't that great, but it's super portable, and it's able to do almost all of what I need it for the computer to do. And I need USB ports. I need headphone jacks to do my content and product creation. I need a big screen. I don't want to always plug into a monitor, and I want to be portable. And I don't want thick, giant, graphics cards with a lot of heat. So now that I know, and what I don't like is it still has a CD drive slot. I'm not using it. Have a hard drive in there instead of a CD drive, but maybe in a new design we can get rid of it and keep all the other ports. Some of these are obsolete ports, but with designing your own thing, you can add or delete whatever you want. So now This might seem obsolete, but this is just a pad of paper. Now, what does a pad of paper have to do with 3D CAD? Well, you gotta start somewhere, and it's easy to forget things. So, because I found that a lot of laptops don't have the right dimensions for the lightness and small size, and have a giant screen, I want to keep this kind of form factor, so I'm going to do a little bit of reverse engineering. First, get a tape measure and just measure what, in my real life, what I like in products, I want to emulate, and what I don't like, remove. And so, because I understand that this is a comfortable shape and size that I've used for many, many years, I know that that's something I want to keep and replicate. So we're going to take some dimensions here, 15.5 by 10.5, and just keep track. Just doesn't have to be perfect, just have to, this is where you start. So it was 10.5, 15.5, measure twice. And thickness. And you could probably get all these dimensions online, but this is a general rule of how to start from nothing. And there might be products out there that you want to iterate off of that don't necessarily have documentation anymore. So you have to kind of, retrace the dimensions. A little under 3/4 of an inch, but we'll just, about 3/4 of an inch. And this is how you start. And then you can record everything and pop it into the CAD program. And now we have a part A as our reference. Usually you want to start with the main piece that you're going to be of your new product. So it's either the largest piece or the piece that everything gets attached to. In this case is the chassis. So we start with the chassis, and that's the main part A, and then everything else gets screwed onto it and attached to. And that type of design method is what I like to call design constraints. So we have literally a volume of space that we've chosen as the ideal volume of space that we want to keep everything inside. Anything bigger would be too big to fit in a backpack. Anything smaller, well, the screen would have to shrink, and I don't like that. So this is called a design constraint. You have to figure out what that is. Whatever product you're making, whether it's a pen, whether it's a flashlight, you have to decide how big you want it, and which just basically constrains what you can fit into it. How big, for a flashlight, how big a light can you fit in there? How big batteries can you fit in there? For a laptop, how big a screen can you put in there? Any product, you have to have constraints, and it has to be based in reality. How is it comfortable to hold in your hand? And that will drive the rest of your design. Now, nothing is figured out right now. It's not like, okay, this is fixed, set in stone. It's just a starting point. And all the details as you go forward will be fine-tuned from there. But for now, that is enough to get started. So before we start, I'd like to just basically select the type of 3D CAD tool we want to use. So you don't have to choose the same CAD tool I'm using. I'm using Autodesk Inventor. You could use whatever you want. I'm just going to show you some different ones. or how are you able to like get the software to begin with? Well, SolidWorks, Autodesk, uh, Siemens NX, Creo, Parametric, they all are 3D CAD tools that all of them have 30-day free trials. I would suggest using those. They're all, I would say, and why I say it doesn't really matter is because at this point, after many, many, many years of development of all these CAD tools, they are very similar at this point, and a lot of features that were only found, like very advanced features, for example, in Siemens NX, they had very advanced direct modeling tools. I don't have to go into too much detail, but let's just say that Autodesk Inventor now has what was only available in like these high-end, like for big corporations level type of 3D CAD packages. And so I would say they're very much equal at this point. The Siemens NX type CAD packages still have features that are somewhat advanced, but it's not a big difference as it was before. So you'll be just fine with SolidWorks, Autodesk Inventor. And another thing about Autodesk, they do have an entrepreneur impact program. So if you do have some sort of a clean tech type of idea or company you want to start, they will help you out with free software. And so that's how you're able to get your CAD package installed and ready to go. And then you might want to do that. And then you can use the 30 days of the free trial, just kind of going through the tutorials. All right, so going back to the CAD tool. So also, not all the features are exactly the same, but of all the CAD programs, but the basic ideas are very, very much the same. So you want to start off first organizing your project. So how do we do that? Well, you want to actually first make a folder for where you want your CAD tools to go. I'm calling CAD folder is going to be PLM tutorial, and I've already created that folder. Also, you want to make a separate folder outside of this folder for in the future where we're going to store like nuts and bolts and screws and washers and all that stuff, hardware file. So just create a hardware CAD file folder, and that's where all your whatever components you can get that have 3D CAD files is going to go. And the reason you want it separate is because if you had everything in the your project folder, your main project folder, and let's say later you want to make another product, all your screws and washers are going to be in this other project folder, and it's a very hard time trying to link them together to use the same parts between projects. You want to separate them out, and that way you don't have to keep linking to this. Like, let's say you made a laptop, now you want to build a car. You don't want to keep referencing screws and washers from a laptop project to a car project. You want to keep hardware in a separate hardware folder that is not linked to some obscure project that you may have abandoned or whatnot in the past. Or and let's say it was abandoned, you want to delete it, you're going to have to move all your screws, and it's just a nightmare to manage. So keep them separate. And we're going to make a new project. So you just click on the project button, menu opens up, you click new, and then just what type of project are you creating? New single user project, next. Project name, I'm just going to call it just laptop, generic kind of name. Doesn't have to be anything crazy. Select the folder that you just created, and
And that's it, finish. And it generates a project folder. And now you're locked into this project, and every time you want to switch a project, you have to close everything you're working on in that particular project, and then you can move to another project. It's just a way to organize things, and it does a pretty good job. And here also below once you create the project, you can actually add another library. So in the libraries, that's where I would put my hardware folder that I was talking about earlier. So your hardware folder is going to be in a separate folder. Well, you'll just add that path to the libraries here. And that's where I'm going to put a link for the hardware folder, hardware CAD files. Click OK. Save. And done. So, and I guess it automatically kind of sees the hardware that's in that folder and kind of gives you some preview files. So just to show you where this is all going, I do have a somewhat of a finished product that I can show you. Why is all this organization necessary? What does it all mean? So let me open up an assembly, and also along with a drawings and whatnot that go with that. And so this is all part of the product life management, which includes communication with vendors, documentation, revision control, and maintaining your parts list and getting quotes and all that stuff is the features that are basically possible by the features that are in this tool, and these are basically the goals of where all this is going to lead to. So first, we have what's called an assembly, and this assembly is a bunch of pieces of the final product that is assembled together in 3D CAD. So we have plastic cases, 2 halves that are screwed together with 3 screws. Screws are a little hard to see because they're actually somewhat transparent. I think the model came out as transparent for some reason. And then inside this plastic case, we have a battery, circuit board, and some other empty space. Now, it's not 100% filled in. There's also a switch and a heating element that's not in here. This is actually a portable soldering iron called Solder Doodle that I invented. And let's see. This is going to be not quite the, this is actually part of the final and the finish line, but not quite the finish line. The finish line is when you actually get quotes and you get, you send out documents to vendors for them to actually get your quotes for all the finished product. So the models are also linked to documentation that actually look like this. So this is the 3D model projected onto what's called a 2D drawing, which is used not only for inspection, so we have dimensions that need to be maintained, and if they're not, it's considered a reject, it won't fit, but also it has other information, including revision. So this revision 17, for example, for this document, that means we've gone through 17 different revisions, updating each time and notifying the vendor that things are changed with revision history, making sure that they're not using an outdated version, and also in the notes where we actually have standards, quality standards, materials, finishes, and any other information that's critical to making this thing function and maintain quality of the product. So all this is necessary. Tolerances, we'll get into all these details later. I'm just showing you the finish line, what it looks like. And then after that, that's basically what is needed right before you even order, go into production. And this is basically your communication tool with all factories and vendors. It's not just creating a 3D model. If I just sent a 3D model, none of that information is communicated as far as inspection and quality control issues. 3D model is basically you can think of it as a bookkeeping tool. We just need to know if things are going to fit, and the 3D model will tell you. But it will not communicate to the vendors the final product quality and what is considered a bad part that should be a reject, or what is considered as a passing part due to variation in machine tools and like this dimension here, 0.037. Well, the machine that makes this part isn't going to hit that dimension exactly each time because it's impossible to meet perfection. In reality, there's variation. Now, how the variation is going to basically determine what's passing or not. If there's too much variation, and it's all in the specification here. Here's the tolerances. If it goes beyond this tolerance, then it's considered a reject part. Right now, we're not at the technology where a 3D model can just be sent to any factory around the world and all that information is passed on. So we still have to use this type of communication in all production of all product ideas and everything. So whatever tool you use, it has to include all these communication features that enable you to not get stuck and hit a brick wall, and you won't be able to provide the information required to go into production. Okay, that's enough for getting set up. And actually, let me show you one more thing. Now, I said create a hardware folder. Well, what does that mean? And to have a hardware folder with nothing in it. Well, it's not going to be empty. After working on this project, we're going to actually start filling it with things. And let's, for example, a screw. McMaster Car is a perfect website, mcmaster.com, for these types of hardware supplies and also information. And for example, building up a hardware library for 3D CAD. And the reason is that they're able to do this is for years, any type of hardware, screws, bushings, you can just type in anything, and bearings, whatever, any hardware, you might want to check out McMaster Car first. And what you'll find is they've organized things very, very clearly, very easy to navigate. And once you find your product or hardware or screw or whatever, and you go to the the ordering page and look at the product details, they almost always have an option to save a 3D model of the part, and a universal formats, also some specific for SolidWorks. I prefer the 3D step format, and this means that it's kind of a generic 3D model. Doesn't include a lot of I call it a dummy part because it's just basically a block of the features of the screw or bushing or whatever. You can't really modify it, but that's not the point. You just need a placeholder to have it show up in your 3D model so you can check for interferences or fit, form, and function. And then you just hit save, and then it will be downloaded, and then you just move it into your hardware folder, and that's it. You want to try and not have to create a screw from scratch or a bushing from scratch, or you want to get as much CAD information and CAD files from companies, from third parties as much as possible, and build up that folder, hardware CAD folder, and that way your life's gonna be much more simpler, and you can design much faster, and you can get ahead much faster than you think with this type of thinking. And try to assume that things have been invented. If you think, hey, I have this idea, maybe I have to design it from scratch, check the internet first. Make sure it's not already been designed and available for download. And that way you're going to save a lot of time. Other CAD sites that I like is grabcad.com. So that's going to be maybe things you can't find on McMaster-Carr, things that are more fully assembled, or even products that you might not be able to find on the company websites. Like someone has created a 3D model of an entire graphics card. The graphics card companies aren't going to give you their 3D models. So I can just, computer. I can get, all sorts of different assemblies and CAD models that you might be able to find there. Another good site, it's kind of very popular, DigiKey. Now, they're not as easy to navigate, I want to say, as McMaster-Carr. However, they do an okay job. If you, for example, if you just start searching for things like fans or whatever, and then in the search, you can click on items that have CAD models already and apply that filter. You can navigate through, and when you go into the product detail, you will see that here's a step file, .stp. That means step. That's the generic CAD format that you could pull into your hardware CAD file, CAD folder, and you can download that. So that kind of simple, knowing how to get files and import them into your 3D CAD model, that is half the battle right there. So we're just going to be aware of this as we go forward, and what we're going to do is go right into the just doing the chassis of this custom laptop that we're going to design. So I'm going to close everything and go into my new project. There we go. So now I'm in the laptop project file that we created earlier, and all you need to do is go into the new folder button. Click on the new folder button, and we're just going to use the standard part. Double click that. And we're in the basically empty space. Now, before we go, I did your user interface might look a little different. I actually went to the options and adjusted the display So I like a white background. I don't like grid lines. So in options you can adjust the way it looks, but this is what I like. So what do you get in with a new empty part? Well, for free you get an origin with a center point. It's hard to see, but it's a little yellow dot that's in the middle. You get 3 axes, X, Y, and Z, and you also get 3 planes, Y, Z, X, Z, X, Y. If I turn them all on and made them all visible, you will see it's kind of, creating this kind of 3-dimensional, like, intersection. So that's the 0, 0 origin of this entire empty space. I'll leave these on just for reference, so you guys will know what I'm clicking on. After a while, you do this so many times, you just know that they are there even if they're invisible. So the way this works is we're going to input the dimensions that we measured earlier off the laptop, which is, and in order to do that, we can't draw anything yet until we actually click on a certain plane that we want to sketch onto, and then basically we're going to draw on a surface, like drawing on paper basically, but drawing on virtual 3D work planes. So I will choose the XZ plane. I think it's just one of those, the way it's oriented. If I go to top view, I could imagine my laptop looking at it from the top. So I'm just going to click on this plane as if I'm going to just sketch on the paper from the top. Now it's not exactly, necessary, but what I find is if I do things and draw things in the way that I would be interacting with the product, that when I go to assembly, I have an easier time assembling them because they're kind of already oriented in the direction that I want to assemble them, and I don't have to like rotate and rearrange things as much. So I'm going to hit Start 2D Sketch. So now we're basically in sketch mode. So I'm able to draw on this plane now. So anything I do here will basically be on that plane and nowhere else. Now I'm going to draw the base of the chassis. And what you want to do for the most part is try to draw and sketch in a way that is centered around the origin. And when I draw I'm going to draw a rectangle to just create the general shape of the chassis, laptop chassis. But what I find best is to draw using these kinds of center point defined shapes. For example, rectangle, 2 points in a center. You can choose different ways to draw a rectangle, point to point, or what have you. But it's a little bit harder to get, just to hit that center point with that. So I'm going to do the center point rectangle. And if I just kind of hover over the center of this, the origin, it kind of does a snap to it and it turns green. So it means I'm actually hitting that. So it's actually really easy to find the center. So, and so it turns green. I wiggle my mouse. I know it's snapped, and I'll just hit the left button, click it, and release. Another thing is muscle memory with how to click. So I'm going to try and describe the clicks as much as I can of what my finger's actually doing, because I know even a regular AutoCAD from Autodesk is a little difficult for me because my muscle memory is not it's not the same required to do those clicks in Autodesk AutoCAD. So it's kind of a retraining that I have to do if I use AutoCAD. So once I get kind of a general idea of how this shape is going to be. It doesn't have to be perfect. You just then I'm going to click again, and it's just yeah, a click and release. And so now we have undefined rectangle. We're going to go back in and put in dimensions now to make it the dimensions that we measured earlier. So I'm just going to click dimension up here, the dimension command. Click on this top line of this rectangle, and I'm just going to left click and release. And then I'm basically have this dimension that's kind of in space, and I'm going to left click and release again to place it. And now it's giving me the option to enter the dimension, which I'm going to type in, and we measured 15.5 inches. And if you like to do metric, you could do metric. You'd have to create a new folder. Well, it's easier to start with a new part in metric than trying to convert later. But this one's we're going to do in inches. And so I'm still in the dimension command. So now I'm going to click on the other side of the rectangle. Left click release, drag, left click release. And then I'm going to enter that dimension, 10.5. And that's it for this particular sketch. So now I could hit finish the sketch. We're done, just giant green check mark. Click it. And now we can see that we're looking down on this kind of projection of what our chassis is going to be. So the next step, we don't have a third dimension yet. Everything's 2D. So to get to the third dimension, we're going to hit this extrude command. And that will, you can only use it once you have a sketch. So let's click that now. And now it's going to automatically detect there's a sketch there, and it's going to basically want to extrude. Extrude just means pulling that shape, that two-dimensional shape, and pulling it, out and expanding it outwards. And we're going to do this, which is the thickness of the laptop chassis, and which we measured as 0.75. I think it was a little under 0.75, but we'll just do 0.75. It doesn't have to be exact. I can show you a few. I can show you just quickly some other features of this extrude command. You can also extrude at an tapered angle, for example. So you can make it almost like a pyramid, extrude as a pyramid, so it's not pulling out, straight up. It's actually kind of pulling out and kind of, squeezing the rectangular smaller as it goes. But we're going to leave that as 0. We don't need to do that. But just showing you some different options in this extrude command. You can also change the direction. Instead of pulling up, we can push down. We can pull from both sides up and down. But we're just going to go one direction. Hit OK. And OK, we've got a slab, a block. And that's not a very good laptop chassis, is it? So this is our volume that we're going to work with. So this is our first design constraint. Now, if we want to make it look good like a MacBook, we're going to probably have to do a lot more tricks than just this. So we can start off simple. We're probably not going to add all the features for mounting everything, like the motherboard, the fans, the heat sinks, or whatever. We're going to do that later. But for now, we can play around with just a simple command to kind of get you an idea of where we're going to go. So we want those nice round, MacBook kind of corners. So what I like to do, and you could do this in sketch mode, instead of make a rectangle, kind of make a rectangle with rounded corners. But I like doing it after I extrude, because these fillet commands which is basically rounding your corners. Um, it's not just rounding. You can also do inside corners and make them not a sharp on the inside. But these fillet commands are easy to edit, update pretty easily, and I find when I try to make a rectangle in sketch mode with round corners, it's much harder to modify after. So we're going to hit this fillet command, and we're just going to start clicking on edges, sharp edges, all around, all four. We're just going to see how that looks, and if it looks like a MacBook, then we're just going to call it good. I'm going to go in and edit it. You just click in the text box under the radius column, and you just type in numbers until you like it. So it by default it was at 1/8 of an inch. So I'm going to raise it to 1/4. Now I'm going to raise it to 1/2 an inch. Just see how it looks. And I go, okay, that looks like an okay type of curve. So I'm going to say okay. Now I hit click to add. I'm going to add another radius. So you just right below that text box was a click to add button. So you just click that, and we're going to, in the same command, add another radius. And this radius is going to be for the bottom of the laptop. So we're going to make that smooth also. So I don't want that to be as big as the actually, now that I think about it, I should not have this, because I can tell that it's going to treat this side as a non-continuous side. And let me show you what I'm talking about. So I'm going to hit OK first. I'm going to show you first what I mean. So we're going to do it this way by selecting everything in one command. And let's see what happens. Maybe it will automatically make it a continuous radius. Let's see. Okay, never mind. It worked. So it did the fillet commands in order. So it actually filleted this first, which created this curve, tangent curve, and then it did a fillet to that tangent curve also, which is good. So you can do that in one shot. Instead of having to do two separate fillet commands, one after the other, you can do it all in one shot. So I think that's a pretty decent laptop chassis. It's still solid. That's not good. So we're just going to do a simple way to make it hollow. And that is called the shell command. So we're going to go up into the shell command, and we're just going to do a simple shell, and we're going to pick the surface that we want to remove, and it kind of gives you a little preview of what it'll look like. So like we're going to click this, and we're going to what thickness do we want this chassis to be? So the thicker, the stronger, but also the heavier and bulkier. So but if it's too thin, it's like paper, and it'll be very weak, and if you drop it, it's going to dent very easily. So you want a nice medium kind of, we don't want 1/4 inch, but 0.1 inch is okay. 0.06 inches is also pretty strong. We can go right in the middle if we want super strong, maybe 80 thousandths of an inch. For example, a piece of paper is 5 thousandths of an inch, which is, 0.005, and this is like what it would look like if the aluminum was like a sheet of paper aluminum, and that's like a foil. That's like made out of aluminum foil. You don't want that. So we're going to go much thicker than a piece of paper. So maybe 30 sheets of paper or whatnot. You want minimum. So we're going to click OK, and it will automatically remove that. And it's a continuous thickness, so even on the bottom, not just the walls, but the bottom of this chassis is also 80 thousandths of an inch thick. And it also this radius, it's following the contour of the fillet that we just created on the inside, and so that radius is not the same radius on the outside, and we can prove that. You on your keyboard just click the M button. That gives you a measure command, or you can click up to the tools menu and hit measure, but hotkeys are a lot faster. And then you could click on that radius. You can see 0.125 inches, which is what we expect. And then on the inside, actually want to hit escape, get out of that, hit M again for measuring a radius again, and we can see that it's 0.045, so it's smaller, which makes sense because if you're going to make a contour around of thickness contour around a 1/8 of an inch radius, the inside radius is going to be much smaller than the outside, so therefore the small radius on the inside. So that's a good start. I think as we go, we're going to add more things to this chassis. Screws, screw holes, threads, ports for plugging in all sorts of connections like power, monitor, USB. How do you put the battery in here? What all these kinds of questions we're going to have to come up with solutions for, and this is the process. And the way to think about this is you just any idea you have, just throw it into 3D CAD. Just see what comes out. There's no way I could have predicted what this was going to do, and you'd be surprised not a lot of people who do product design do either. You just have to jump in, see what it looks like, modify it, and see how you can get it to work. There might be times where you might have to redo it. I mean, worst case, even if you have a good tool like this where you can easily modify things, like if that fillet was not good, I can just double click on the fillet. See, I just went to in the model tree here, it shows everything that I just did. There's all this history of exactly what I did. You just click on the feature that you want to modify. You say, that radius, I think it's too small. Let me make it. I need just a little bit bigger. Instead of 0.5, 0.6. You just type 0.6 and hit OK, and it updates. Nothing's locked in stone. Even with all these features that are easy to update, there are some cases where there is so much variables and so many part modifications that sometimes do crash the model. But if you follow these steps and you organize it in such a way that that possibility reduces quite a bit. And tools like this will help you in that. So we're going to go ahead and save this. So you just on the top menu, just hit save. And we're going to call this laptop chassis.
So I think that's a good place to stop right now. I'd like to continue these tutorials teaching product life management practices, continuing the addition to the assembly for this laptop prototype, using this as a way to explain tolerancing, 2D drawings, communicating to vendors, and going through all the details, how to put things together, how to assemble things, how to align things and making sure things fit, and showing how it's very straightforward. Anyone can do this as long as there's just kind of a few tips and tricks on how to reduce the amount of confusion, clutter, walls, or maybe even potentially crashing the CAD model by doing preparations beforehand that don't get you into a tough spot. And So you can share, like, and subscribe if you like what you see. If you have any comments, please feel free to put comments, what you like, what you don't like, what you'd like to see. And then I think going through this process as if you are a designer, going through the motions of going from idea to an actual product launch, gives you the idea of what tools are actually necessary, and it will also guide you into like what tools out there that will be useful to you. Do they have these capabilities? And if they don't, chances are you might get stuck down the line going using tools that don't have these features. So thanks.